All right, welcome back. In this chapter, chapter number 10, we'll talk about files. And mostly when we talk about files, these are textual text files where the data is kind of in the purest form. It doesn't have too many hidden characters. All the files we deal with, such as Word file, Excel, PowerPoint, and many, many other files, there are literally thousands of types of files. They have some hidden characters built in based on that particular application, that program. The text files are pretty simple and straightforward. So we will learn how to read these text files and how to write to these text files. And once we learn how to write simple data or how to read the simple data from these files, then we'll explore maybe some functions to read all the way to the end of the file and so on and so forth. So in this chapter, what we'll do, we'll learn about input file and output files. We'll learn about how to use loops to process the entire file, and then how to pick up the data and use arrays, how to process these records once we have picked up the data from a file, how do we bring it to our program and process it, and also control break logic. And then we'll see the implementation into three languages as we have been doing for some time. Now, files, I'm going to move this one a little bit here. When a program needs to save data for later use, it writes the data in a file that can be used later, because everything you have in the memory, in the random access memory, it is for short time. If you remember from chapter number 1, it's volatile memory. Volatile means it needs source of energy. So if I want to save my data, I must save in an appropriate type of file. For example, you have Google files, or you have Microsoft Word, Excel, Access, Word, PowerPoint, and there are thousands of different types of files based on which program you're using. These days, we use PDFs and so many different types of files. So in previous programs, you wrote the data was stored in variables. Now, file input and output can interact with various types of applications. You have the ability to do the input and output with word processors such as Microsoft Word, image editors, spreadsheets, games, web browsers, and many, many other types of files as well. So there are three steps must happen. We must be able to open that file. If the file is already in existence, assuming the file already exists, we should be able to open that file. And at the end, we should be able to close that file. All right, so opening and closing is necessary because this file belongs to a different set of applications, different programs. So if my compiler, let's say I'm in C++ or Python or Java, I should be able to connect to that file. I should be able to open that file, and I should be able to, once the file is open, bring the data so I can process the data from that file. All right, so an output file means creating and preparing it for output. An input file means opening a file and preparing for reading purposes. Now, the input purposes, the file should be in existence. For output purposes, if the file does not exist, then my compiler or my program will create one at the time of the execution of the program. Once the file is open for reading purposes, assuming, or even for writing purposes, then I can process the data and I can write the data or read the data from that file. All right, we'll do both of those things in just a bit. Then closing me must be done to disconnect it from the program. So because if you have the file kind of open and then you want to let go that file because you have already read the data, you have already processed the data, so you want to close that file. So in that way, another application later on want to use the data from that file, they should be able to open it correctly. Now, this is the file I was referring earlier. This is called text file. Text file typically has an extension .txt or .dat. These are very simple, primitive kind of data files because these files store data without too many of these extra hidden characters. And there are a bunch of hidden characters. We will not be mentioning all of them here. I'll mention only a couple of them a little bit later. So those contains data that has been encoded as text or using simple ASCII kind of rules. So, or in some cases Unicode, but ASCII rules. So even numbers, in this type of file are stored as text. Everything is stored as text. So then I can bring the data to my program and I can process the data. So on the other hand, the binary file contains that has not been converted into text. A text editor is needed to view the contents of that particular binary file. We'll be dealing mostly with the text files, mostly with this kind of file in order to bring the data from data actually is readable. Even if you open a text file without compiler, without bringing it to your program, you can read the data from that file in most of the cases. Now, files can be accessed in two ways. The sequential access, it's an access which is like a linear access. So you start from the beginning, you go to the next, to the next, to the next, and that's how we go through the sequential file. So for example, if you're in line number 1 or row number 1 or record number 1, then you go to the second record, the third and fourth, and in that particular sequence. So that's what it's highlighting here. Data is accessed from the beginning to the end. All data must be read. So this is the sequential file. Now these files are really easy to manage because you don't need any special handling. You can actually open a file, start reading the data from that file. On the other hand, there's another type of access, it's called direct access, also called random access. Any piece of data can be accessed without reading the data that comes before it. So you can go in the middle of that particular file and bring the data from that file. So we will be only focusing, because we are just learning how to open and read the data, we'll be focusing only on sequential access. We will not be dealing with the direct or random access. All right, so far so good. So files that are created should be given a name with an appropriate file extension. And you probably have been doing this for years. Whenever you create a file, let's say you have an English essay, or you have a history report, or you have some kind of a transaction. So you probably have two things to the file. You have the name of the file, and then you have the extension of the file. The extension is very important because extension, many times you don't give an extension. It is given automatically based on which program you're using. If you're in Microsoft Word, it might give an extension .docx. If you are Excel, .xlsx. So it depends on which particular application you're using to work on that particular file. But the name is given by you. If you don't give your own name for that particular file, then that application might give a default name. So those are the two things important. So we just need to be careful that when we are trying to read the file, and we give the name with a dot and with the extension. So in that way, the appropriate file is identified and we can open and close that file. Must also create an internal name that is similar to variable name. So here, because this is the customer file, which is called customer.dat. So in my program, I should be using some kind of variable, some kind of placeholder, which kind of matches with what kind of data I'm bringing from that file. So if I'm bringing customer data, so here it is, you can see this is the variable I'm using. So for the developer, for other team members, they can see this particular variable is kind of connected to customer.dat file. And output file indicates the mode in which the file will be used. As you can see, output means this is for output purposes, for writing purposes, and the customer file is the internal name used to work with that particular file. And in both cases, we'll see the input file when you're trying to read something from a file for reading purposes, and output file is for writing purposes. All right, so here we have, this is our name of a file. This is this file, assuming file must be opened. So notice that it is in double quotes. And again, remember, this is just a pseudocode. We'll see the exact syntax in respective languages in a few minutes, but you can see the name and the extension of the file is given. And we are saying, open this file and assign this variable to this one. So this variable is kind of connected to this particular file. Again, syntax varies a little bit here and there, but just for the sake of understanding, assume that this file is connected to this variable customer file. Now, once that is done, then you can write, for example, you want to write something right there. So you can write customer file equals this one. Or you can also say declare string name this and use the variable name. Same kind of step, but this one actually has two steps and this one actually has one step. Most of the time, you do not have the hard-coded data in the program. You are bringing the data from an outside source, from a user, from some other source. And then once the file has been written, let's say we just wrote that particular piece of data in that file, then you want to close that file. Remember, this is not a real syntax from Java, Python, or C Sharp, or C++, sorry. This is just for your understanding what exactly happens. We open a file, we write to the file, and we close that file. Remember those three steps? It's just showing you those are the three things. In this particular screen, we are not writing anything, we are not reading anything from a file. We are instead writing to the file. But those three things must happen. We should open it, we should read or write, and we should close the file. Now, just want to make a comment here. Some languages, if you forget to close, they don't give you a syntax error. They might give you some kind of issue later on, but in many cases, the compilers, they close those files or disconnect with those files automatically. All right, so there are some hidden characters. One of the hidden characters is called EOF, end of file. And end of file marker, a delimiter, is a predefined character or set of characters that marks the end of each piece of data. It separates the different items stored in a file. An end of file is a special character or set of characters written to the end of file. Now, how do I know the file is ending after row number 15 or page number 7? How do I know that? So there's a hidden character which tells the program, doesn't matter Microsoft Word or Excel, or doesn't matter it's a text file or it's a PDF, it tells that particular program, this is the end of page 7 or this is the end of that entire document. So that hidden character is very important for us to understand so we can actually continue to read that file until we find EOF. Now, do not worry about it. You don't have to look for it. We have EOF in many languages given to us, and we can simply check in our loop. If you do not find end of file, continue to read. If the end of file has been reached, then in that case, you can stop reading. And I'll probably demonstrate that one once we get to the demonstration part of it. Now here in this case, we are learning how to read the data from a file, and a variable must be declared. So here's my input file, here's my variable, and this input variable indicates the mode in the file will be used, which is for input purposes. An inventory file is the file, real file. Let me correct myself. Inventory file is the variable, which is used internally, and input file means it is for input purposes. Remember, we saw for writing purposes, this is for input purposes. All right, so this is the name of the real file. I want to read this file. This file already exists on the system, and I'm using my variable to open that file. So remember, that's the first step. But before I get to the first step, I must declare inventory file, which I did it right here. I declared it. And again, this is just a pseudocode, just a reminder. So this is not exact code. It's going to vary in Java versus other languages slightly. And once that's done, and then I'm ready to read. So I'm reading the item name, and I'm basically reading it by using this variable. And then once I'm done, I can close that particular file. All right, so again, we did 3 things. Technically, we did 4 things, but 3 things are necessary here. Open a file, read a file, close a file. But in order to declare this one, we declared it right there. Okay. Now, append mode. Append is basically many times when you have an existing file and the file has some data into it, you have to be very careful. What if you want to add more data to it? If you're not careful, there's a possibility you might overwrite that particular file. When you overwrite it, all the existing data might be lost. Imagine if this is your master file, which has thousands, if not tens of thousands of records. And if you're not careful, and instead of writing all the way at the end, it might delete everything and write just one record into it. So you have to be very careful. So in addition to read and write, append mode also exists to add data to the file that already exists all the way at the end. I want to add the data at the end. If the file already exists right there, that's what it's saying, it will be erased. Be careful, be very careful. By the way, this does happen people who are not careful. People have lost everything. Companies have lost everything because they hired a person who was incompetent or not a good person to be placed in that kind of position. I remember 15 years ago or so, the state of Alaska, they lost everything from the state employee. One of the state employee basically destroyed everything. So if the file does not exist, it will be created. When the data is written to the file, it will be written to the end of the file. So append mode is very useful. It is something we want to do. And again, this is not how we do it as far as program is concerned, but this is just for your understanding that it is a necessary step. Now, loops can be used to enter large amount of data. In fact, that's how we do it. Because if I want to enter a bunch of sales and want to write these sales into my file, so I should not be doing one at a time. I'm going to run some kind of loop. As you can see right there, loop is being run. And we can also read in a loop. In fact, we do that extensively. If it's not end of file, notice there is a function called EOF. EOF is reading sales file, and we say not end of file. Notice this not here and not operator. Remember in one of the chapters, I think chapter 3, when we start talking about conditional control structures, and I mentioned the logical operators and, or, and not, and I had alluded to it that not operator is very powerful. Without not operator, there are a lot of things you cannot really do. It will become very cumbersome without not operator. Now here, simply by putting not, what it does, it says if I do not find the end of file, and the file is the last hidden character in that file, could be thousands of pages, then I'm going to continue to read. And that's exactly what we are doing here. We are reading, reading, reading until at one stage it finds end of file. If it finds end of file, then we stop. Otherwise, it reads and displays the content in that loop. Just a couple of lines of code and it becomes very powerful. Without that not operator, it would have been very difficult. Then files and arrays can be used together, and the contents of an array can be saved to a file. Open the file, use the loop to step through each element of the array, write the contents to a file on each iteration, or vice versa. The contents of file can be read into an array. Open that file, use the loop to read each item from the file, store each item in an array, just like you can do with the simple variables. Once you understand how the data behaves, you can use arrays for large amount of data as well. So data is stored in a file, is frequently organized in records. Now, let me spend a minute or 2 minutes talking about record. So your individual characters are not very meaningful to us. Like an individual character is character I, character G, character V, for example. These are individual characters. These are not very useful. By combining these characters, either numbers or either characters, then they become more meaningful. For example, all the first names, all the city names, all the zip codes. These are useful fields. Those are called fields or columns. Even fields and columns, they are not very effective until we have combination of different fields, combination of different columns. All the first names, all the last names, all the zip codes, all the city names, all the email addresses, on and on and on. That collectively for one individual is called a record. A record belongs to one person, one entity, which is very useful for us to look at. For example, here, Ingrid has this ID number, has this department field, and on and on. It could be 150 different fields. So the record is a complete set of data about an item or about a person. A field is a single piece of data within a record. Like a stated field itself, yes, it's fine. First name, for example, but itself is not very effective. Now, when you are reading the data, you have an ability to read character by character, or field by field, or record by record. So we'll look into those in next few slides. So writing records, an entire record is done using a single write statement. So you can say write employee file name, ID, department. So all three things, name, ID, department, you can write to employee file. And as you can see, it is for writing purposes. You can also read in a similar fashion. You can say read name, ID, and department. So entire record can be read that way. Now, when you're reading those or writing those, you have to be careful because you need to know the sequence, how the data is laid out in a file. If you do not know the sequence, you do not know how the files look like, you'll have difficulty. So you need to know how the file is laid out, how the data resides in the file, and that's how you can read and properly write as well. So it says algorithm can be used for adding records to a file, searching for specific records, modifying record, and deleting. And those algorithms are a little bit more advanced. We will not be discussing in this class, but there are ways we can actually figure those things out. So program performs some ongoing tasks such as reading items from a file, but temporarily interrupts the task when a control variable changes its value. When this happens, some other action is performed and the program resumes its ongoing task. So control break logic is basically is telling you either the new record has come up or the record has ended and so on and so forth. Now, see, file contains the following sales data. So we have different store numbers, we have different states, we have sales. So store number 101 in North Carolina has sales of $10,000, for example, and we have a bunch of other records. Now our task is to produce a sales report showing the total sales for each state. Notice that we have North Carolina, 3 of them, Georgia, we have 3 of them, and Florida, we have 3 of them. So we need some kind of internal total based on that particular state. So it's not very hard to do that. So here it's just showing that in this particular case, the control break logic is the program will read the records, keeping a total of sales amount. So for each state, our goal is to keep track of the individual sales for that particular state. When the program notices that the state has changed from North Carolina to Georgia or from Georgia to Florida, then it will print the total and then reset the total to 0. All right, so it's a logical thing. It's maybe 1 or 2 lines of code, and we can easily figure that out. So as long as North Carolina is being read, we'll continue to add the totals to the total for North Carolina. When it switches from North Carolina to Georgia, then we need to reset our sum variable or total variable so we can calculate the total for Georgia or Florida. So this program uses will then continue this program until there are no more records to be read. So it should look like this. So all the store numbers, the states, and notice that individual sales as well as the grand sales for that particular state. Same thing for Georgia, same thing for, there's a mistake here. It should say Florida, not GA, Florida. All right, so this is how we can, this is very interesting what we just discussed. Let's see how we can do in some languages. Some languages are really, really easy to do these things. There's no additional coding needed. Not too much coding is needed, especially when we get to C++, and you'll see how easily it is done. Some languages, there are additional things, but majority of the time you have to include or import a library. Here, java.input-output io.asterisk, you need to include that one on top of your program. And notice that this is your output file. So this we can see it is for output purposes. And we are creating print writer. This is the name of the file. So this particular student data will be for output purposes. So, and then we can say output.println, gem, and pay rate. And then we close that file. Okay, so this is your close your file, and this is how you can open your file. All right, and let's look at this one. And then in this particular case, we are putting everything in a program. So your library is included on the top, and we are doing exactly the same thing. This time we are reading a file called philosophers.txt, and we are adding writing the names of these 3 philosophers in that particular file, and then we close that file. All right. So this time we're appending the data to an existing file. Appending means we have to be careful. We are not overwriting it. So you will say student.txt and you make it true here. Make it true. And then open that file writer, new print writer. This statement opens an existing file named student.txt. The contents of the file are not erased, and when you use the print line method to write the data to the file, the data will be appended to the end of the file. So it's just basically adding just extra line of code. In C++, you will see that it's just comma in APP for append, and it does it for you as well. So here we are opening a file to file and reading text from it. So you're using these two libraries, and this one is you're opening a file, and this is your input file, and you can actually use next line. Next line basically allows you to read a string, and next integer to read the next integer, and next double to read the next double data type. Again, you need to know how the data resides in that file. So if you want to read the entire line will be read as a textual content. But what if you had some names, some real numbers, some whole numbers? So you wanted to process them. You wanted to do some kind of calculations. So next line only allows you to read the whole line, whole record as one string. Sometimes that's not very useful. Sometimes you just want to read as whole numbers or as real numbers. And then you close that file. And this will be a little bit it's an application of the same thing here. So you have my file, and then you can say my file dot next line, next line. You're reading the data into name1, name2, name3. Those are the local variables. These are the variables declared as strings, as you can see. So the first record, which you read from a file, it is stored in name1, and the second one in name2, and so on and so forth. Then you display it on the screen just for the user to see. And you can say here the names of those three philosophers, which were read from a file. So here, focus on detecting the end of file. So we are figuring it out if we have reached the end of file, which we alluded to it earlier. You can use the scanner method has next. So has next is to determine whether a file contains another item before you attempt to read an item from it. So in this case, we are using has next in a loop. So if there is more data, then it can be read from a file. The has next method returns true. So has next basically returns true if there's more data to it. But if there's no data, it has reached end of file, then it's going to has a false value. If the end of file has been reached and there's no more data to be read, the has next method returns false. And you can see how easy it is implemented and verified with the, as you can see, there's no complicated program you have to write. You're just using an existing has not next function, and then it will allow you to. And in C++, you'll see there's an EOF function. It works very similarly. And then whatever you read, like in this case, you're reading the double data type, you store in sales, and you display. All right, let's look at some of the implementation in Python area. All right, so in Python, you can use the open function in Python to open a file. And here it is right there. The open function creates a file object and associates with the file on the disk. So you can have the file name and the mode. So there are three types of mode discussed here. There is a R mode right there. Open a file reading only, for reading purposes only. The file cannot be changed or written to. So sometimes you just want to open a file for reading purposes only. For W mode, open a file for writing. If the file already exists, erases its contents. If it does not exist, create it. So be careful with that one, because this might basically overwrite it. And A is open a file to be written to. All data written to the file will be appended at the end. If the file does not exist, it creates one. So be careful with these. So you can open a file. Here's your variable. And again, you don't need extra declaration of the variable name, because Python, as we have been seeing for the last several weeks, it is a much more modern language. It does take care of all the things in the back end. So we simply give the file name here. Let's say the file name is student.txt. So you will put that in double quotes, and the mode you want to read for read purposes only, for write purposes only, or append purposes. And here it is. So you have a customer.txt, and you can use single quotes here. And then you can use the read only purpose. So whatever, when you open that file, You have a customer file is connected to that variable, is connected to it. So after this statement executes, the file named customer.txt will be opened, and the variable customer file will be will reference to a file object that can use to read the data from a file. All right, how do I do for write? All you have to do is change to W and whatever the name of the file is. For this is writing purposes. After this statement executes, the file name sales.txt will be created in a variable. Sales file will reference a file object that can use to write data to the file. Remember, this one is kind of, you have to be very careful. The sales.txt already exists. It's going to overwrite it. Be very careful with that one. So when you use the W mode right here, you're creating a file on the disk, brand new file. If the file with the specific now already exists, the contents of the file will be erased. Be very careful with that one, guys. It can be devastating for an organization. Their historical data, 20 years, can be erased like in one flash of a second. Now, file variable dot write string. So writing to files. So file variable is a variable that references a file object we saw in the previous slide. Now string is a string that will be written to the file. Now string could be, you can have, and we'll see that different examples just in a bit. It could be a hard-coded value, or it could be a value of a variable type. So the file must be open for writing purposes. All right, so when you have file open as a W or A purposes, then you can write hard-coded value like this one, name of a philosopher. Or you can actually use a variable, name variable, and name variable can be used. This is a preferred method because most of the time you're not hard-coding the value inside the program. You are basically using variables which are probably reading the data from a user or other sources. Now, how do I put it in the program? So here's my main function. Here's my main function begins here. Here I'm opening a file for writing purposes right there. So here's my variable out file. And then I'm actually adding those three things to my, writing those three names to the file. Notice that there's a \n. \n basically is a carriage return or enter key. So \n basically gives you the enter key. So once John Locke's name is added, the next name, David's name, will be added in the next line and the next line. So it's a good practice to add that one, or you can actually store this one in another variable and you can add the variable as a concatenation, which we discussed that one, I think in chapter 2 or chapter 1 of the chapters earlier. Then you can close that file. Once this function is available, then you can call that function. This is how you can call that function. Remember, the main function is required in Java, C++, C#, and C language. It's not really required in Python. Python, they created more like a free-flowing kind of a language, but it is also creating a main function just as a starting point. Once the main function is up and running, then you can call that function and trigger it. And it says these are the marks of the line of, I already explained that to you. Here we are reading the text from a file. So we are using readLine object. Method returns a line of text as a string from the file. The file must be open using the W or A mode. And here we are reading the content input dot the read line. And then this statement reads a line of text from that particular file. The line of file is returned as a string, and then the string is assigned to a variable my text. So here main function begins here. So we are using for reading purposes, and then we read the line, 3 lines by read line. And then we read one at a time, and we store the data into line 1, line 2, line 3. And then we are ready to print. We can print it here. All the data will be printed, and you call the main function right there. Okay, nothing terribly difficult to understand. Very easy, and we are just going through the motions here. So writing numeric data to a file, numbers must be converted into strings before they can be written to a text file in Python. In Python, that's kind of something we need to do. So use str function to convert a number to a string. So here's a number. So let's say this number is a whole number. So we are using string, converting to string format, plus add the new line, the enter key. This is \n is the enter key, appends to a new line, and then you can write to the file. So originally the number was like this, 99. So we converted into this format by doing str. So that's what the str does. Oops. And that's what the str did it for us. And then we put it in the program. This is just the same code. We put it in the program here. We are enter a number, and the number is given by the user. It is taken as a number. And once the number has been taken, then convert into a string and write to a file. Okay. And then readLine methods returns a line of text from a file as a string. So if you're reading in Python, let's say 10, 20, 30, 40, these are the numbers that look like numbers, but they are read as strings. So for example, the numbers in the following file would be read as like this, as strings. So we must be able to convert into numbers for numeric purposes, for computation or analysis, statistical analysis purposes. So that's what it's saying in your book here. Before the number can be treated as number, they must be converted into numbers. And we have a function called int, function to convert a string into an integer, or the float to convert a floating data type, which is a real number or double data type, into number from the string. And that is actually happening right here. And we are expecting we want to read this data. This is for reading purposes. So this is the name of the file. This is the file which exists here. Open that file, and we are ready to read the data. So data will be read. First 10 will be read. As soon as we read 10, we convert into number, a whole number, and then close the file. And of course, if you have a loop before it, it's going to look for the entire content, which you can see right here. So detecting the end of file. So the readLine method returns an empty string when it is attempting to read beyond the end of file. So again, in Python setup, so readLine method returns an empty string when it has no more data left. This makes it possible to write a loop that determines when the end of file has been reached. So let's say we are trying to read for reading purposes. As you can see, we're opening this file for reading purposes right there, read mode. We are reading the file. Every time the record is stored in line, and we are checking here, do you have an empty string? Right there. There's an empty string here. Do you have an empty string? If not empty string, display the data and then read the next line. At one stage, after this is going to go through thousands of times or hundreds of times, depending on how large the file is, it's going to find empty string. When it finds the empty string, then it exits the loop. Using the for loop, for loop, again, you're reading the same exact file for reading purposes. So read one line and from that file, print that one and close that file. All right, so now we will move on to the last part of the discussion, which is how do we do in C++. So in C++, we have a library called file stream library, fstream library. You need to include that. If you have been using C++, you probably have iostream library, string library, there are a bunch of libraries, CMath library. So this is another library you will be including on top of your main function. And this fstream library has two objects. One is called offstream for output file stream. One is called ifstream for input file stream. So whenever I want to write something to the file, I must use this object. And how do I do it? Like right there. So I'm creating this variable of this type. All right. We did the same thing Java in Python as well. I'm creating this variable, which is output file type variable. And this must be of this type. So once that's done, then I'm ready to open that file. And this is it. So basically there are three lines you just need to be aware. One is including this library. One is if it's output purposes, you create a variable of that particular type, either offstream or ifstream. We'll see the ifstream in just a few minutes, but offstream basically allows you to open that file for writing purposes, to write something to the file. And this is the name of the file, assuming this file does not exist. If it does, it's going to overwrite it. Be careful, guys. Be very careful. It's going to overwrite it. We'll see the append just in a bit. But right now, assuming this file doesn't exist, it will create that file and it's going to start writing the data to that file. All right, so how do I write it? So just like we did C out, if you remember in C++, C out less than symbol. So use the less than operator, these two operators with C out, just like what we did. So instead of C out, because we are using the file variable, so we'll use output file less than Jim, and it's going to write on that particular file the name of this individual. And ENDL gives you the new line. All right. So assuming the pay rate is variable, the following statement writes the value of the pay rate variable to the file. So you can write the name of the data stored in this variable, whatever the pay rate is, let's say $40, well, whatever, if it's a whole number 40, if it's a real number 40.55, and it will be stored in that file by using a variable name. And how do you close the file? You can close that file. All right, so let's look into one more time. In fact, I need to go back here. So you will be including a library, you'll be opening a file, and you will be, opening a file is happening here, and then you'll be closing the file right here. All right, and in the middle, you can process the data. You can read the data or you can write the data depending upon how the file was created. All right, so this is what I mentioned earlier. So here's a full program, fully functional program. This is output stream, input output stream. I will also include the string library. I will highly recommend you include a string library. The string library helps you to deal with the textual data. So then you have the maximum numbers, 5. There's a constant declared, some kind of counter is declared. And here's your output file. This is for output purposes. Here's your file is being opened here. The name of the file is number.txt. So we're going to write these numbers 1, 2, 3, 4, 5 in this file. And we run some kind of loop. And I recommend highly, there's no need to declare it separately. You can just simply say int counter here, but they did it separately here, but regardless. So counter less than numbers, which is 5, counter plus plus. So every time we write something to that file, so it's going to write 1, 2, all the way to 5, because maximum number is 5. And once it hits 5, and there's an equal sign here, so that's why it's going to reach that maximum value of 5 as well. And at the end of the loop, you can close that file. Opening a file for reading purposes, first write include, okay, same thing we saw earlier. This time we'll be using if stream, not off stream. Remember we did off stream here, which is, we did it here, off stream, right there. This time we'll be using if stream. If stream is for input file purposes, if stream. So this is the variable name, which is of if stream type. Now I'm opening for input file purposes, for reading purposes. All right. So I can read the data. I can read a value. So the read text from the file use the greater symbol, just like with cin we did. The following statement reads a line from the file from that particular file and assigns to a string, assuming that value is a string. Did it declare it here? It did not declare it here, but assuming this particular value is a string, and it reads the string. And because of this object, we have the ability to read the file by using these greater symbols and close that file. Let's look at in the entire program. I do recommend highly. In fact, if you don't do it, it's going to give you an error message. You do include string library here. All right, so we declare a couple of variables, and there's a maximum size here. And if input purposes, because that's what we are trying to do, open that file. So numbers.txt already exists. It has some numbers. We want to read those numbers. We run this particular loop 5 times. Pick up the first number, display it. Pick up the second number, display it. Pick up the third number. At one stage, the maximum of 5 is going to reach. Then this loop will be exhausted, and then you close that file and exit out. Okay, last couple of slides, guys. We are almost there. Now, What if I have to write something and I'm being careful and I want to append? Append means I'm going to write the data all the way at the end. So you will use declare an offstream object to reference the file. It should be offstream, guys. It should be offstream. They made a mistake here. It should be offstream object. And so this should be offstream, not fstream. Fstream is just the name of the library. So open that file. This is the name of the file. And remember, this is for writing purposes. And here I will say app, iOS app. App is for append, for appending purposes. So if this file is already in existence, it's not going to overwrite it. It's going to go all the way at the end. The new data will be added at the end. So this statement opens up existing file, friends.txt. The contents of the file are not erased. And when you write on the data on the file, it will be written at the end of the file. How do I do this? So here it is. And detecting the end of file. So this is the last thing it's highlighting here. And there are easier ways to do it. In fact, I'll actually probably provide you a demo file, much easier. But this is how it's doing it here. So this greater operator returns a true or false, indicating whether the file was successfully read or not. If operator returns true, the value was successfully read. If the operator returns false, that means the value was not read. So here the file is for input purposes, for reading purposes, and we are using right there. We are using that variable we created here, right there. And we are, for reading purposes, reading the number. So what it's telling you, when it returns true, then the value was successfully read. If the operator returns false, it means there's no more value. So this is one way to do it. But sometimes you do not want to do that way because there's an end of file EOF function exists. And you can use that function as well. And I'll probably put a demo file for you. If all the data has been read successfully, you display the number and close that file. All right. So we are done with this chapter. In this chapter, we learned how we handle the files. And in many textbooks, in many cases, they don't even talk about files. They skip this chapter. I just wanted to highlight this chapter and importance of this chapter because when you go to the university, you might have a project or two where you have to read an existing data from a file, from the web or other sources. So just wanted to put that one make it available for you. So if whatever language you're using in a university, Java, Python, or C Sharp, you have some background. Oh, sorry, should say C++, because I used to teach C Sharp as well. That's why every time it says C Sharp. But so you have the ability to see how data can be read and written to a file. All right, guys. So we are all done, and hopefully you learned something. And we'll see you next time. Bye bye.